I start with drawing a diagram of the projectile motion equation. I then use the x and y kinematic equations and subbed in the values we were given, such as the initial velocity and distance. I then use simultaneous equations and rearranged x for t, and then sub that into the y equation. I then, using mass rules, I rearranged the equation for tan. I then subbed in g equals 9.81 into the quadratic formula I created when I rearranged the equation to a, b, and c to simplify the amounts I got so that it was easier to do the quadratic equation and formula. I figured out the two values, which was 75.62 degrees and 50.14 degrees. I use the smaller range because I use a larger angle because it will have a smaller range, as seen on the diagram. The pink one with the larger range with the larger angle has a smaller range. So I use the 75.62 degrees. Then to figure out the minimum range, I subbed in that angle into the projectile equation of range. I subbed in the initial velocity and the degree and gravity values, and I got 3,065 meters. From there, I could calculate the safe distance from taking away the 2,500 meters and 300 meters from the total distance calculated, and this here is the leftover zone for our safe zone, which ended up being 265 meters.